Good morning, class. We are continuing our lesson plan title, which is chemical reaction. And you did an awesome job with that on yesterday. Our topic differs. We are talking about a combustion reaction. Our objective today, we want to write and explain why a combustion reaction has occurred. And of course, we're doing standard 5B. Our bell ringer, I wanted you to explain bird migration in your own words. And so you have done that. And so we're going to brainstorm your ideas. Would anybody like to share with me the process that birds use to migrate from one area to another area based upon the seasons? Would anyone like to share what you think?
I think it's more seasonal, so they according to the seasonal change, they go to where the climate is going to be adequate for them to survive.
Very good. Anyone else? Great answer. Great answer. Would anyone else like to share their ideas?
Well, based on something you've said previously,
Okay.
it's as if they have some kind of innate
Fantastic.
thing going on where
Mhm.
they react to the earth
Exactly.
field and then they know to go.
Great. Now, on yesterday we said that a chemical reaction was a what? What was a chemical reaction?
One that brings about a
Yes.
Change.
Yes.
reverse.
Very good. So our vocabulary that we want to deal with is combustion reaction. Our lead-in that we want to take and apply to everyday life. The 4th of July, what usually happens around the 4th of July? What do they usually do? They go and buy a lot of stuff, like fireworks, New Year's, right?
Mm-hmm.
And what's so fascinating about the fireworks?
Yeah, different kinds, just a big explosion.
Oh, a big explosion. And you have just identified the reaction we're going to talk about today. So a combustion reaction is simply a big what?
Explosion.
So when we get this big explosion, ooh, what are some things that's going on?
Chemical reaction.
It's a chemical reaction. What else?
Physical change.
Physical change. Okay. Does it get hot or cold or
Gets hot.
gets hot? It even burns some people's houses down, doesn't it? All right, because some people won't even let you use them in the city limits.
Right.
Okay, very good. What we want to do, we want to identify some things that will let us know that a combustion reaction has taken place. If I wanted to light a candle, and the candle is burning, and if I take a jar or something and put it over that candle, what's going to happen?
It's gonna go up.
Why? Why is it
Don't have
going?
any oxygen.
Oh, you have just identified a combustion reaction. So you're telling me in order for a combustion reaction to take place, it must take place in the presence of
Oxygen.
oh, you are just awesome. Fantastic. So if you would just look at some things, I have an example here of a combustion reaction. On your handout, I have wood plus oxygen. Do you see that?
Mhm.
And I have this arrow, and I got this little ink mark there. Why do you think I have that there? I have a little dark colored spot there. Well, first of all, what are we burning?
Wood.
And once we burn the wood, it's going to turn to what color?
Black.
Black. That's why I have the little black dot there.
Okay.
The black dot, and then when you burn something, because if we got a fireplace or a heater, why do we have those things in our home? So they can give out what?
Warmth and heat.
Warmth and heat. That's why I got plus heat. So that's how a combustion reaction looks. Got to have some oxygen. Okay? And then when you react it, or when you ignite it, then you're going to have a new substance plus some heat being given off. Are the questions so far? All right, let's look from your handout. We have what we call a synthesis reaction. A synthesis reaction you are taking two different things and you're bringing them together to make one. Say for an example, all right, if I had A plus B, then it's gonna come over here and become AB. That's a synthesis reaction. Well, sometimes a combustion reaction can be a synthesis reaction, all right? If it's in the presence of oxygen and it has two more things and it comes together in your product as one thing, then you can classify it as both. If you will look at your handout, I gave you an example of a synthesis reaction, but I want to ask you a question about that. I have CaO, and then I have a small s. I have a small s, and let me just put that reaction up here. Ca, and then I have O, then I got that. What do you think that S represents? Right here, that S right there. What are the three phases of matter?
Solid.
Liquid and what? Gas. So what do you think that S represents?
Solid.
So that lets you know that that's not a liquid and it's not a gas. That lets you know what you're dealing with in your reaction. So that's plus H2O. And what kind of symbol you think I'm gonna put here? Oh, awesome. Then it comes over here and it becomes Ca. Then it becomes OH2. And then I got small s. Now, that is and I'm gonna put this right here. This is another reaction. This is C, then it's S plus O2, and that's a G. What does that G represent?
Yes.
And then that's CO2, and then G for what? Gas. Now, one of those is a combustion reaction. Now, both has the same form. I combined these two things and I ended up with one thing here. I combined these two things and I ended up with one thing here in my product. But only one represents a combustion reaction. Which one is it?
Yes.
Is it the first one or the second one? Because in my reaction, I had what present?
Solid.
Now, what must happen in order for oxygen? Fantastic. I have carbon, which is a solid, plus the molecular oxygen. So that makes it a combustion reaction, even though they have the same format. But now sometimes you can react oxygen here. If oxygen had been here, then both would have been a combustion reaction. The question. Our objective says that we want to write and explain, and we've done that, why a combustion reaction has occurred. It will occur if it's in the presence of what? Oxygen. The questions so far? All right, if there are no questions, let's look at methane. This belongs to what we call the hydrocarbons. Hydrocarbons, you only have three elements present. And those three elements are carbon, hydrogen, and oxygen. So if we would look, I want you to tell me, once I put this chemical reaction up, I want you to tell me if I put up methane, which is CH4, and plus 2O2, and this is a gas, and then it yields CO2 gas. And I'm going to ask you another hard question. Plus 2H2O, and that's a gas. Now, is this a combustion reaction?
No.
Is it a combustion reaction? Yes. If oxygen is on your left, if oxygen is on the left of your arrow, we call that a reactant. And like when you're multiplying 2 times 2, and the answer in multiplication is 4, and that's what we call product. So over here, this is our product. This is what we've gotten when we react these things together. So we're saying that this is a combustion reaction because oxygen is present. All right, that's good right here because oxygen is present. Now, very hard, think about it. Remember we said sometimes a synthesis reaction can be a combustion reaction. Is this a synthesis reaction here? Very hard question. Remember, this is my example. This is the form you would use for a synthesis reaction. Is that a synthesis reaction? No, because you can't have but one clump, one hole in the product. I got a plus sign here. Can't be a synthesis reaction. It must have this form. But it is a combustion reaction because it's taking place in the presence of oxygen. Other questions? You sure? Okay, so what we have done, we have identified symbols that we would use to represent items that we're dealing with, okay? Of course, everybody knows that oxygen, you can't see it, but you can breathe it, so it's a gas. Has no shape, it has no volume. And then, of course, liquid, it has a definite volume, all right? And then solid has a definite volume and shape. So we've identified those things for you. And sometimes we won't know unless we actually, look at the product itself. Other questions thus far? In our experiment that we're going to do, we will follow our objective. What we're going to do is actually, in the presence of oxygen, we're going to actually do a combustion reaction, all right? And we know that a chemical reaction would have taken place because the form would change, and we do have oxygen. Now, why do you think if a person is burning and they start running and they tell you, don't run, drop and what? Roll. Why do they not want you to run if you're on fire? It increases the oxygen. All of those answers are fantastic. So those are combustion reactions. It must have oxygen. If it does not in the reactant, now I'm not talking about in the product, because it's not going to form product. It's not going to form oxygen in your product because you're going to use that up to start it. Okay? Are there questions? Are you sure? Well, that's it. Just give yourselves a hand. Oh, aren't you amazing? All right, that's it.